So everybody knows his part.
Yep.
And who is getting the microphone from.
Yeah.
And the timings and
yeah.
if you got it wrong, don't worry. This is just internal. So let's try a couple of runs. So we are live now. So just to try to practice, I will play the video.
Good afternoon, everyone. My name is Isidro Durazo Cárdenas. I work at the Center for Lifecycle Engineering and Management. I wanted to welcome you to the Rail Innovation Test Area at Cranfield University. This is a particular lab where we do experiment with the research projects that we do have with Network Rail. What we see here at the back of me is a workhog vehicle, which is part of our research. And it will be doing a demonstration of rail inspect and repair. I just wanted to remind all people looking at this that there is a space for question. Please ask your question at the box at the bottom of this. Thank you.
Hello everyone. So this is our demonstrator Warthog, and the whole system is made for railway inspection and repair. The main purpose is to find the defect, do some mimic repair task, and also create the command and control center for the whole system. So the Warthog has many sensors. At the top, we have the LiDAR, and we have the environment camera with a 360-degree view. We can zoom in, zoom out, pan, tilt, everything. We also have a RTK GPS, and in front of it, we have the UR10E manipulator. This is a 6-degree of freedom manipulator. In front of the manipulator head, we have a monocular camera for finding the defect. So in terms of the defect, we have a QR code, which is representing a defect in the railway environment. Yeah, so what are we expecting today? So first of all, the vehicle will start from a base position. It will run along the track, and the arm will move to inspection pose. Once it finds the defect, it will stop and do some actuation. So these actuations are mimicking the repair task in a railway environment. So let's go for the demonstration.
Thank you, Miftah. So let's start our demonstration. We can see the Warthog And the demonstration is finished.
Hello everyone, this is Ade. So I'm here to talk about the sensors we have on board on the Warthog. So on the Warthog, we have the LiDAR, which releases laser beams around the environment to pick up some obstacles. And we have the GPS, which reads the geoposition of the Warthog in latitude and longitude. These positions are converted to distance, which can be used to measure the distance traveled by the Warthog. Also, we have the environmental camera, which is installed on board to pick up environment and send signals to the Warthog. Under that, we have some processing unit that takes all these sensors and fuses them through some certain algorithms in the Warthog, and then we can have some operational characteristics which can be controlled. I'll hand over to Mezume, which is going to demonstrate the Warthog of geoposition.
Hi everyone, my name is Masuma Rahimi. I'm a PhD student at Cranfield University at the Center of Life Cycle Engineering and Management. My research is about developing and implementing autonomous localization and navigation for the robotic inspection and repair system. The main component of this robot is Warthog from ClearPath company. This robot has a number of sensors such as RTK GPS, 3D LiDAR, RGBD camera, and an IMU and a wheel odometer. As this robot is considered to operate on the railway track, localization is highly important. For localization, we mostly apply GPS sensor, but GPS is not working properly in railway environment because of different reasons, such as tunnels, dense vegetation, unavailability of the satellites, and many other reasons. So in this case, we try to use sensor for vehicle localization and apply trackside objects as references for improving vehicle positioning. Next, I will show a couple of videos in order to relate it to the on-track vehicle localization and navigation and off-track autonomous vehicle localization and navigation. This test is divided into separate phases. The first phase, it is supposed that we have GPS. The vehicle starts moving in order to reach to the goal location. And in RVs, you can see that localization and mapping are running through RTAP map. And in RVs also, we can see a graph base that are generated from the RTAP map. In the related terminal, we can see that the GPS location has been reached. In the second scenario, suppose that we do not have any GPS. So this is the case that the vehicle, the vehicle need to identify where and when to stop in order to identify the defect location. Here, the vehicle starts moving and use the trackside object as a reference point in order to specify the environments around the defect location and also improve the vehicle's location. Here we can see that by detecting the distance from the nearby objects, it starts publishing, and when it reaches to the defect location, the vehicle would stop.
And now you can stop.
Okay, yes, I'm back. It's still real life, and you heard from our colleague Mezume, who she demonstrated the navigation protocol installed on the Warthog. We discussed earlier about the obstacle avoidance, which is done by the LiDAR, and I'll be handing over to GN to give us a demonstration of that experiment.
Hello everyone, at Robot Life. I'm Jian Li. I work on the software development for this robot. This is our latest railway robots and automated bench trolley. It has similar feature as the Warthog robot we talked before. The main difference is it's railway ready. It has the wheels ready to go on the railway track without any conversion. Today, I'm going to show you an example of collision avoidance with the LiDAR sensor. Our LiDAR works by sending beams 360 degrees to the surrounding environment up to 200 meters, so it can have a clear view of what's around you. Today's demo, the robot will travel to the end by detecting this obstacle, which is the fake policeman, and eventually slow down. It will continue moving when the obstacle is cleared until reach the end. Now the robot start moving. Now the robot detects the obstacle and stop. The robot will stop unless the track is clear. Now we clear the obstacle, the robot continue moving. Hello, this is Jen. Hello, Robot Live, this is Jen. Now I will repeat the job sequence, but this time I'll share the screen, show you what does the robot see on the what does the Warthog see on the robotics arm. Now the robot is repositioning itself to look on the side of the track for any defect. Position ready.
Yeah, so we can see the trolley is moving along the track. And from the camera view, we can see the camera is capturing the videos of the rail. It's approaching to the QR code. Yes, from the camera view, we can see it detected the QR code. So the robot arm pose at different positions and capture the QR code from different directions. And then the job sequence finished.
So we have seen successful demonstration of Warthog finding the defect in the railway environment. In real life, this has a very good impact of increasing the safety of human who is working on the rail, and also it can be cost and a benefit. This demonstration has also been carried out in real railway environment at Northampton and Lamport Heritage Railway site, and we have seen good results there as well. So don't forget to keep commenting and asking questions. Our comment section is open for everyone, and thank you for watching our demo.
I think I'll bring a screen on Wednesday so that you can see the comments.
Okay.
Because here I can, when there are comments, I can show them on the screen.
Okay.
Yeah. So I'll bring the screen so you can read the questions as I post them. Okay. So the first question, is it the position accurate?
Okay.
Maybe.
Do you need more time for explaining?
And lots of questions to tell me.
Okay. We don't know exactly to what reference, but it's very accurate.